This is part 3, focused on fraction multiplication concepts and visual representations. Make sure you have your guided notes for part 3 in front of you before you continue. Okay, so what is multiplication? When we learn about whole number multiplication, we often learn about multiplication as meaning groups of. So as an example, 3 times 2 equals 6. We learn that conceptually this means we're looking for 3 groups of 2, or 2 groups of 3. The commutative property of multiplication tells us that we can switch the order of the factors. So 3 times 2 equals 6, 2 times 3 also equals 6. And we could look at an array in either way. 3 groups of 2 or 2 groups of 3. Fraction multiplication is a little bit different. So when we're looking at 2 proper fractions, 1/3 times 1/2 equals 1/6. Conceptually, what we're asking for is 1/3 of 1/2, a fraction of a fraction. Or the commutative property still holds, 1/2 of 1/3. We can switch the order of the factors. So if we're looking for 1/3 of 1/2, we look at 1/2 and then look at 1/3 of it, and the product is then represented by the overlapping area here. Or if we're looking at 1/2 of 1/3, we would start with 1/3 and then find 1/2 of it, and our product is the overlapping area here. Okay, the direction of effects for fraction multiplication or for any arithmetic operation is our expectation of the relative magnitude of our solution in relation to the terms in the problem. So for whole number multiplication, the direction of effects rule says that the product of 2 whole numbers is always greater than either factor. So as an example, 4 times 3 is 12. The product 12 is greater than 4, and it's also greater than 3. For 5 times 2 equals 10, our product 10 is greater than 5 and also greater than 2. So students learn to expect when they multiply that the product or the answer they get is going to be a larger number than the numbers in the problem. This holds true, this direction of effects rule holds true when students multiply improper fractions, so fractions that are greater than 1. Multiplying 2 improper fractions always yields a product greater than either factor. So as an example, 6/4, that's an improper fraction, or a fraction that's greater than 1. 6/4 times 8/4, another improper fraction, equals 48/16, which simplifies to 6/2, which simplifies to 3. So 3, the product, is greater than the first factor, 6/4, and 3 is also greater than the second factor. Or 3 is also greater than the second factor, 8/4. So the same direction of effects rule holds for whole numbers and for fractions greater than 1 when we multiply. However, the direction of effects rule changes for multiplication of fractions less than 1 or proper fractions. When we multiply 2 proper fractions, we always get a product less than either factor. So as an example, 2/5, that's a proper fraction or a fraction less than 1, times 1/5, another proper fraction, equals 2/25. 2/25, that product is less than the first factor, 2/5, and it's also less than the second factor, 1/5. This direction of effects rule leads to a lot of confusion for some students. They have grown used to multiplication with whole numbers where the product is always a larger number than either factor. When we transition to multiplication of proper fractions, the products are smaller than either factor, and that can be confusing for students. Sorry, these little orange footnotes here, number 1 and number 2, alert you to guided notes items that you should fill out. So pause here, go to your guided notes, and fill in the missing information for number 1 and number 2. Then come back when you're ready. There are some common errors that students make in fraction multiplication that can relate back to their undeveloped fraction magnitude understanding. So in multiplication, fraction multiplication, it's common for students to unnecessarily find common denominators or to keep a common denominator constant when they should multiply. So as an example, here's a common error. For the problem 3/4 times 1/3, a common error is finding a common denominator, in this case 12, and then multiplying across numerators and keeping that common denominator constant. This results in a product of 3 for this arithmetic problem. So for fraction multiplication, you don't need common denominators. Students often carry that over from what they learned about fraction addition and subtraction, and then overgeneralize it or use it inappropriately when they multiply. This is another common error. In this case, we've got 3/4 times 2/4. The student multiplied across numerators and then kept the common denominator here constant. So what they should do is multiply across numerators and then multiply across denominators for a product of 6/16, but instead we've got a wrong product here, 6/4. If we look at what can happen with these common errors in context, it can help us understand how this relates to magnitude knowledge. So this first error, 3/4 times 1/3, a student finds common denominators and then gets a product in the end of 3. If we think about this problem in context, we can see how this answer just doesn't make sense. So 1/3 of the plants in Zach's garden were pepper plants. That's our 1/3 here. 3/4 of his pepper plants were ghost peppers. What fraction of the plants in Zach's garden were ghost peppers? So this problem, this is a fraction multiplication story problem. It's asking us to find a fraction of a fraction. 1/3 of the plants were pepper plants. 3/4 of those pepper plants were ghost peppers. So we've got 1/3 of the total plants in the garden were pepper plants, and 3/4 of those were ghost peppers. This overlapping area here represents the product. Here's the correct multiplication. 3/4 times 1/3 equals 3/12, which simplifies to 1/4. So if you see 3/12 here in the overlapping area, it simplifies to 1/4. 1/4 is a correct product here. 1/4 of the plants in Zach's garden were ghost peppers. This is very different from the answer we got here, 3, when the student made this computation mistake. Multiplying two proper fractions always yields a product less than either factor. So when the computation is done correctly, 1/4, that product is less than 3/4. 1/4 is also less than 1/3. So the product here follows the direction of effects rule for proper fraction multiplication. This makes sense. However, this product, 3, is greater than either factor. It violates the direction of effects rule, and it doesn't make sense when we think about the problem in context. Here's another visual representation of the problem. So again, 1/3 of the plants in Zach's garden were pepper plants. 3/4 of his pepper plants were ghost peppers. So 1/3 of the plants were pepper plants. And then if we split each third into fourths, we can find 3/4 of 1/3 represented at this point on the number line, which is 1/4. So 1/4 of all the plants in Zach's garden were ghost peppers. Okay, let's look at another problem in context. So this is the other common error. When multiplying two fractions that already have a common denominator or the same denominator, keeping that constant as you would in addition or subtraction. So in this case, when they made this mistake, a student multiplied 3/4 times 2/4 and got 6/4 or 1.5. When we look in context, we can see how this doesn't make sense. So when the movie was almost over, Vinny had 2/4 of his bag of popcorn left. Veda grabbed the bag and ate 3/4 of the remaining popcorn. How much of the whole bag did Veda eat? So there was 2/4 of a bag of popcorn left. Veda grabbed it and she ate 3/4 of what was in there. We're looking for a fraction of a fraction to describe the amount of the whole bag that Veda ate. She didn't eat 1.5 bags. She ate a portion of a bag that was already half full. So this answer doesn't make sense. Right? When we multiply two proper fractions, we think about the direction of effects rule, the product should be less than either factor. In this case, again, we've got a product that's greater than either factor. It doesn't make sense. If we look at a visual representation, right, this is Vinny's bag of popcorn with 2/4 of the bag of popcorn left. Veda grabs it and she eats 3/4 of what was in there. So this is the fraction that represents the amount of the entire bag that Veda ate. Here's the computation. So 3/4 times 2/4 equals 6/16, which we see 6 cells here overlapping out of 16 total, and that simplifies to 3/8. This product, 3/8, is less than 3/4, and it's also less than 2/4. It's a fraction of a fraction. So it makes sense that this number should be smaller than either factor. Okay, and just on the number line here, so there's 2/4, that's the amount of popcorn in the bag when the movie was almost over. And then to split 2/4 in 2/4, again, to be able to find 3/4 of that number, we land at this spot on the number line, which is equivalent to 3/8. Okay, now we're going to estimate and apply this direction of effects rule to computation to determine if an answer is reasonable. So, looking at this problem, 11/24 times 24/50 equals 23/100. What we're asking here is this product, 23/100, reasonable? And we're going to determine if it's reasonable based solely on this rule. The product of two proper fractions always yields a product less than either factor. And we're going to use benchmarks to help us figure this out. So the product of two proper fractions, these are both proper fractions, the product should be less than either factor. This product is, again, thinking about benchmarks, this is about 1/4. 25/100 would be equivalent to 1/4. 23/100 is really close. So this is about 1/4. 1/4. Is this less than either factor? 11/24, this is close to 1/2. 12/24 would be equivalent to 1/2. And 24/50, this is also close to 1/2. 25/50 would be equivalent to 1/2. So I'm looking at 1/2 times 1/2 equals 1/4. This makes sense. 1/4 is smaller than 1/2, and 1/4 is smaller than 1/2. So this product is reasonable. Yes, 23/100 is a reasonable answer. Again, it's smaller than either factor. It follows this rule. Okay, now it's your turn to try out this process. So you're going to apply the direction of effects rule for proper fractions to this problem and determine if the product is reasonable, just based on the rule. Use benchmarks to help you estimate the magnitude of these fractions, and then apply the rule, determine if the product is reasonable. Do that, fill in your answer at number 3 on your guided notes. Pause here to do that, and then come back when you're ready. Okay, let's check your work. So, 30/28 is not a reasonable answer. Okay, our first term, our factor, is a little less than 1. Our second term is a little less than 1. And our product here is actually greater than 1. This is a larger number than either factor, which means it violates the rule. The product should be less than either factor. So this is not a reasonable answer. Now let's look at the rule for improper fractions. Remember, improper fractions are fractions greater than 1. When we multiply two improper fractions, we get a product that is greater than either factor. This is the opposite rule. So let's look at this example. 50/24. This is equivalent to about 2 times 50/50. This is a little bit more than 1. So we've got a number close to 2 times a number close to 1, and our product here, 23/100, is close to 1/4, because 25/100 would be equivalent to 1/4. So 2 times 1 equals 1/4. Does this make sense? No. And if we think about the rule, when we've got improper fractions, fractions greater than 1, our product should be larger than either factor. Our product here is actually smaller than either factor. So this is not a reasonable answer. Okay, you're going to try it out using the direction of effects rule for improper fractions on your guided notes, number 4. Here's the problem. Try this out, pause the video, and come back when you're ready to check. Okay, here's the problem, and our answer should be yes. 110/20, or 110/20 is a reasonable answer. Our first fraction is a little greater than 1. Our second fraction, or factor, is actually equivalent to 5, and then our product is greater than 5. So the product is greater than either factor, which adheres to the rule for improper fraction multiplication. The product should be greater than either factor. Okay, now we're going to work on creating visual representations to model fraction multiplication. Modeling fraction multiplication using visual representations can help make the process visible and show how we find a product. This can help build conceptual understanding of the operation, multiplication, and support students' learning of the procedure, and helping them make sense of the procedure. So when we create fraction multiplication visual representations, we redefine the unit to model fraction multiplication, and we find a fraction of a fraction. You've got a guided notes item here to go ahead and fill out. You can do that and come back to the video when you're ready. Okay, so as an example, when we multiply 4/6 times 3/4, we're looking for 4/6 of 3/4. We redefine the unit as 3/4. Now we want to find a fraction of a fraction. We're looking for a 4/6 of 3/4. So what we find as a product is this overlapping area here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 out of 24 total cells, or 1/2. So you're going to learn how to make visual representations to model fraction multiplication using a series of videos that are in the module. You're going to follow along and actually do the work using paper and pencil on your guided notes sheet. You'll see space to do that from numbers 6, 7, 8, 9, 10, 11. First, you're going to watch the model video and just watch. You don't need to do anything, you're just watching. Then you're going to follow along and make drawings along with videos 7 and 8. Then you're going to try 9 and 10 on your own, then watch the videos for feedback. Then finally, if you want more practice, you'll use the extra practice videos number 1 and 2. So you're going to end this video, work through this practice sequence, and then come back to the next video when you're ready.